Hello everyone, my name is Adriana Ghetan and I'm welcoming you to the Simulate User Summit. A few words about me. I started my career at Grytec more than 10 years ago as a structural engineer. I was responsible for the validation and continuously improving the Grytec products. Later, as a technical team manager, I was leading the technical team of the R&D center of Grytec and team were responsible for the software product quality. Today, I drive the development of the Steel Focus product and as part of the product management team at Grytec Innovation and as the Steel Power Pack manager. In this session, we will talk about advanced design and advanced steel connectivity, how this collaboration between the two platforms can be realized, can be obtained, what kind of connectivity we have between the two of them. Because it's about advanced steel, of course, we are talking about steel projects, which are complex and rich. And why is that? Because we have multiple disciplines. It starts at the conceptual level, it's evaluating towards execution, it's finalized with the real building, and it has many levels of collaboration. So if you think about, we are having a collaboration across certain levels. Let's see which are those levels. So the first one is engineer, architect engineer, so it's from concept to design. Then we have a collaboration between engineer and detailer, so it's design to detail. From the detail to the fabricator, so we are sending the details, the drawings, everything to the to the site, to the fabrication site, yes, where we fabricate the workshop. And then, of course, the collaboration between the fabricator and the contractor, the company who's basically building the structure. So all these levels of collaboration need to have a strong connectivity in order to have a smooth transition for all the steps and in the developing and creating a new real buildings in steel projects. So it's highly important to have strong connectivity between of them. Today we will focus of course between around the connectivity between an engineer and detailer, because we are talking about advanced design and advanced steel. So what about the collaboration? What about that? About the collaboration is the fact that to collaborate well, so to have a strong connectivity, we need to have the right tools. Yes, you need to know how the information is transferred between the applications. So in case of the engineer, the detail between advanced design and advanced steel, and what type of information is transferred. It means that we don't, for example, an engineer does not need all the information that a detailer needs, and vice versa. So we need to control and to know what type of information we are transferring from one platform to another. This is important for the connectivity and for a smooth collaboration. Okay, let's focus on the first point, the tools. Grytec, what type of tools it's offering Grytec to help you to have a good connectivity between advanced design and advanced steel? First of all, we have three main tools, let's say. One is the GTCX file format, the native Grytec transfer file format. The structure designer, it's a steel module encapsulated in two applications, and the SMLX, which is the native Autodesk transfer file format. Let's take one by one. The GTCX, so what is the GTCX file? The GTCX basically is coming from the abbreviation of Grytec Transfer Center Extended, and is the old GTC, and basically it's new because it's able to hold more information than the old one. The Grytec Transfer Center, GTC, it's a communication link between applications and standards. So we have Grytec software and we have other software, Advanced Steel, Revit, standards like IFC, SDNF, and others. So this GTC is a communication link between them. Third point, we need to understand that not always the GTC, so this link, the link which is held by the GTC is the responsible one for all that is happening when we connect or we send the model from one platform to another. So it's not the platforms are all also responsible for some aspects like the export, import, and the synchronization. So particularly this is reading the data from the model and applying it to the model. So in this case, advanced design and advanced steel are responsible to input the data into the model, to reading the data from the model and recreate it in their database format. And we will see that later. And the synchronization, applying the changes, in other words. And well, now we are asking, okay, the GTCX file format is responsible for what? Well, we will see it's responsible for saving and loading the stored information. So when we are exporting the information from the platform, advanced design or advanced steel, it doesn't matter, we are storing this information in a specific file format, GTCX, yes? And also when we are importing from a file. So the component itself, not only the file extension, yes, the component of the GTC is responsible to save, so sending the information in this file and store it there, or to load reading for information from this file and putting it where we need to. Also, it's also responsible for the comparison between two GRITEC models. So we bring a model from when we do the synchronization, it's responsible for the comparison of these two models, and also to manage the synchronization of in the process. Okay, where it's used, this file? The file is used quite in a lot of places: advanced design module, advanced steel, and Revit. The structure designer. The structure designer is an integrated steel module in advanced design and in the Power Pack for advanced steel. The steel structure designer can help you to generate different type of steel structure using the intelligence of a macro. And the model can store all predefined configurations. So in case you need to save the configuration of the structure, you can save it in the library of this application. And also, as possibilities, there are many. You can define industrial structures, mezzanine type, residence type, with multiple bays and multiple levels. So it's highly flexible. Where we can find the structure designer, we can find this in advanced design and in advanced steel under the Power Pack. So if we go in advanced design under the ribbon objects, we will find the first icon is structure designer. And the structure designer, if we develop the drop-down menu, we will see that we have predefined structure that the user can load from the beginning, and then he change a little bit. In advanced steel, under the Power Pack, so you need to have the Power Pack for advanced steel, you have access of this palette, tool palette, or vault, how we call it in advanced steel, the structures vault, which is embedding actually the structure designer module with the predefined structure that we have also in advanced design, and you can load them first as a predefined structure and then start to change until you arrive at what you need. Okay. Next is the SMLX file. The SMLX file is it comes from the steel markup language. It's helping you, basically is the native Exchange file format of Autodesk, and advanced design integrates this file format for better connectivity with Autodesk ecosystem. So advanced design is offering the possibility to use this file format in case you need it. Let's see how the information is transferred. So via the GTCX, we have import-export synchronization inside advanced design under the ribbon. Also, we have some particular options for the GTCX. It means that we can transfer forces or theoretical reinforcement if needed, or mesh. We can export the analytical model, or so only the geometrical part, or also the results in case we want. So it's highly, as I said before, it can hold a lot of information, the GTCX. In advance, still under the ribbon, we have the installing the Power Pack. You have the command under the manage part of the ribbon, and of course you have the same free commands: export, import, and synchronization. Also, the GTCA access in advanced design model is like it's not necessarily an access, but it's the basic of the modules. So we have the RC modules and we have the steel connections, the advanced design modules, and all the data here is stored under a file type GTCX. So is the main file format used for these modules. So this is how it's you can store information in GTCX. Here you don't need to use any more import export. Okay, via the structure designer, so we have predefined structures of the applications. So it's of the application. We have it in advanced design and in advanced steel, and also we have the libraries. So all the predefined structures, but also the one that the user is creating himself, he can store them in the library of the structure designer, under advanced design or under advanced steel. So the structure designer has its own library available on both platforms. Via the SMLX, we have it, as I said, is the basic exchange of file format from Autodesk ecosystem. So it's available under the export and import in advanced steel, and we have the same free type of commands: export, import, synchronization. Then in advanced design, under the same command with the GTCX. So if we go and we want to import or export a file, for example, when we import, yes, we will have the possibility to choose the file type. Sorry, when we export. Yes, so when we export, which we can, by default, it's exporting, of course, in the GTCX file format. But if you need, of course, advanced design is able to handle and to export the data in the SMLX file format. So you just need to change the type of the file when you hit the command export under the file type. You just change it from the combo box, you choose SMLX, and that's it. You save it in this file format. So as we see, advanced design is offering many possibilities to connect with advanced steel. So let's talk about what type of information we can transfer or between advanced design and advanced steel. In this part, we will actually, I will show you directly in the applications how we transfer the data, and we will see together what kind of information we are transferring. So it's much easier for you to understand in practice. Before going to this live presentation, I would like to actually in the applications, I would like to summarize a little bit what type of scenarios we have of transferring the data between the application using the commands export, import, and synchronization. I will talk about the scenarios with GTCX, but in the case of the files format, it's applicable also for the SMLX, except that with the part that SMLX does not need its embedded IT in advanced steel. So let's focus on the scenarios using the GTCX. So the file formats with the commands export, import, and synchronization. And let's start with the first scenario. When we have the, let's say, in the order of the events, the engineer has received the structure from the architect, and he start to build the first model in advanced design. So he start to design the model. And then, of course, he needs to send it to the detailer. He will export it into the GTCX, and using the import command, the detailer will import it in advanced steel and with the power pack. This is a very basic scenario. Of course, another possibility is that in the same company, we can start receiving from the architect the model, we can have it in advanced deal, and using the power pack, we can export it to into the GTCX and then import it in advanced design for the design part. And using the design modules, the designer can accomplish a lot of the part of this project. And a more complex scenario is when we have a round trip around the two programs. So we go back and forth between the applications. So we start from advanced steel using the power pack. We export the data into GTCX, import the data in advanced design, and because we need to go back to the detailing world, we need to send it back, and this time we export it from advanced design, and we use, of course, the GTCX, and we synchronize the models. Yes, via the power pack of advanced steel into advanced steel main model. So we are bringing the data changed in advanced design into advanced steel. Of course, this scenario can apply the other way around. So we started in advanced design, we do the export, the first export, and then into GTCX we import it in advanced steel. Let's say the detailer is starting to work, the engineer maybe is doing some changes in his model, and they need to, or the detailer needs some data from the engineer, and using the power pack for advanced steel, he needs to send it back to the engineer, the model. So in this case, he exports it, and the engineer, in order to get updated the model, he will need to synchronize it, not import it. So this round trip is basically, and then of course we go again, advanced design, export, and then we synchronize into advanced steel. We don't import anymore because we already have the model there. So these are four simple, but of course in the same time they can get more complex scenarios of exchanging data between advanced steel and advanced design. Sometimes it's can be very simple, just one way, because there's no need for more, but if is needed, the users can do a complete circle of changing the information between the two platforms. So there is a strong connectivity between advanced design and advanced steel. Now let's go to the live presentation. Let's see how actually we are doing this using the two platforms, advanced design and advanced steel. So now we are in advanced steel. So we have a steel frame structure already here created. Before going further, so we have the power pack installed. And what is very important in advanced steel is to have the elements defined as structural members. In order to arrive in advanced design, because they need to be designed, so we need to have structural members. So this is a very important aspect. Otherwise, in advanced design, they will not be, the elements will not be imported. So using the GTCX file format under the advanced steel power pack, we export the structure and we go to advanced design. Do not forget to save after export, it's very important. Using the command to import directly in the model, we open the new model, and we just run the import. It's very quickly. And here we have the structure imported. So basically it brings all the geometry of the structure with their properties of materials, sections, and of course other geometrical properties that are available in advanced design, in advanced steel, because the model is coming from there. First we save the model. Okay. We make sure it's saved, and it's very important because we want to have every step saved. Okay, and then we just check first, for example, what is happening around the elements, if they are well connected. First thing we need to check in advanced design. So using the check control option, we can see that there are some issues, and we have some particular comments helping us to quickly fix those issues. It's just quickly in just a few seconds. For example, projection of plan. So we select the elements that need to be projected on a certain plan, and then after we apply this command, we run again the check control to see if there are any other issues in the model. Of course, in advanced design, you do all this you do all the preparation to have a model. Yes, we have the loads, we have the work, the load areas, yes, defined, and we can see very quickly that using the climatic generator, we can have these loads very quickly generated. A very powerful tool of advanced design. Then we generate the combinations. And here we have all our model prepared for the calculation. And we run the calculation, of course, still calculation. After the calculation, we are doing the usually workflow in advanced design. We check the displacement, we check the FEM results basically. Yes, some forces in the structures and so on. Another powerful option in advanced design is the optimization process. So this is helping us in optimize the structure in order to have the right elements, sections in the structure, and the optimization process is somehow a little bit automatic because advanced design knows and propose you a different, in case of need, a new section type. So for this case particularly, we had only one in particular, one particular section who was not okay. Of course, the optimization can be done by section, by element, by design template, many 4 type of optimization process. Basically, you have each time we change the sections, we can we need to recalculate, of course. After the calculation is done, we can export this data in advanced steel back and synchronize the model. So once the design part has finished, we can export the data in advanced steel into GTCX, and then synchronize it in advanced steel. So in advanced steel, we have these, we notice that we have some issues, yes, with the connectivity of the elements. We need to correct those, and using the synchronization mechanism, we load the model from advanced design, and we make some, so we apply the changes. So because we have this, here we can see that the bracings are not aligned, and we will go and check how exactly this is expressed in the synchronization process. So we have the geometry, we have some problem of geometry. So if you see here, we have the geometry of the elements not quite okay. There is a difference between what we have and what we have. what we had and what we have. So we are accepting this, and well, we apply the changes, and we see live that is in the same time. So you are controlling every step. You can notice everything that is changing in the process of the optimization, in the process of the synchronization, and you can also change the type of element. Of course, in this case, for example, we had the change of IIP for change of section. So we want to change and apply this. We accept the changes and we want to apply them. Okay. So the detailer can very easy control what he wants to have. So for example, the part with the in the part of the elements that have uh, moved, yes, they had the problem of not connecting in the nodes for advanced design. So that was a case for the designer. The designer has the need to connect those elements, but the detailer can choose to not connect them because maybe there is a special connection there and there is no need to connect them like this on the axis like the designer needs. So you can choose via this synchronization process how to bring the information you had in advanced design into advanced steel. So it's very easy to, you have a highly connectivity and many details to control on your side as a user. Another possible scenario was with Structure Designer. Yes, so with Structure Designer, it's a little bit different. We don't do any export, we don't do any import. We use just the library of the module to store the data we have created. So it's a little bit of different as a process with file formats, the file formats of GTC and SMLX. So you need to be aware of this process with the structure designer, which we think is very strong and it's very nice to be used. Okay, let's see exactly how this is done in advanced design and advanced steel, of course. So we are in advanced steel. We have the vault of the structure designer, yes, with some basic structure. I will start with the default one. Yes, it's like a macro. It's a macro in terms of advanced steel. This is the terminology we use. And starting from this basic macro default one, I can do the changes I need for my project. So we can define base, we can define how many levels we want. In this example, I chose to define industrial building, so it's industrial framework. Of course, after that, you can, after you define the numbers of bays, you can define the distance between the rows and the bays, and all this you can control basically each parameter of the building. And again, then you go more in the detail. So from the bay, you go actually to the portal. Each portal can be controlled independently. You can control the section, you can control the rotation of the element, you can control the position of the element, if you want to move it slightly or not, if you want to add the center post. So in this case, for example, because it's the end of the building, I added the center post. So for each portal, you can go even more in detail. The level of detail you choose, you are in control of it. But the macro is actually giving you the possibility to use it as much as you can. So you can add more posts if needed. You can set the distance between them. You can do it on the right, on the left, depends on what you need. Also, we will see later, you have the copy above, copy all option. So you just work to arrive at what you need in your structure. You have platforms, you have side rails, you have bracings. In the case of the platforms, those can be an exterior platform or can be interior, depends on how you define them. In this particular example, I chose to do one in an exterior platform. Of course, it can be linked to existing columns, but we can also add more if needed. So the columns from the base, from the portals, can be used as the structure to hold the platform. But in case we need more, we add more, of course. So the level of detail is very well controlled. You have a lot of options. You can define for each element in the structure what type of section to use. You can also, for example, you can place openings. So for example, here we place some openings for the main portal. Let's see, because we will have, I don't know, we need to enter into the building. So in this case, I placed an opening like this, but you can also add particular beam if you need. You can add windows. You can add also cladding. The cladding is something that is related to advanced steel. So after you do this configuration, you save it in the library. So you just save it, like save, using the structure designer. In the library, you already see that we have those predefined structure. Now, if we go to advanced design, this is very easy because, as I said, in the ribbon of objects, we have the structure designer, and we just load it. We just press the structure designer there. It will open automatically the default structure. It depends on the structure you are clicking when you are opening it. But we will see that we have the same structure of the dialog, except the one from the claddings. And if we go to the library, we will see the frame that we generated there. And we just press load. And that's it. So without import, export, without any particular workflow, you just can bring the steel frame from advanced steel to advanced design, or either the other way around. You can start it in advanced design and you can change it here. You can do it here and then you send it to advanced steel. So here we can adjust, we can add, for example, designer needs more. He says, okay, no, it's not okay. We need to have bracings all over the place. I need more here, I need more there. So it's very easy to change the structure in the advanced design as well. So we are doing a few changes. We are adding some intermediary bracing inside the structure, and is the same workflow like in advanced steel. Level the details from the engineering point of view are okay. You can now, these changes can be saved it can be saved in advanced design, in the structure designer module under advanced design. And we had the new frame. Of course, you can overwrite it if you want, but in case you want to have it without the bracings, you never know. You can generate, you can say a new one, updated, yes? So it's just ready. You click OK, you validate the structure, and we wait for the module to close. And here we have it. Under the advanced design, we have actually advanced design elements with advanced design properties, with everything that is needed. What we need to have in mind is these elements are grouped. This is holding the macro, the macro concept. So once we disable this group, the intelligence of the macro will be lost. So it's very important for you to be sure you want to disable it. If you want to change something around the geometry of the element, you cannot, as long as this is a part of the macro, of the group of objects called structure designer. But if you want to, if you are sure of the geometry, it's very easy to disable the structural macro, the integrity of the macro, and then you just disable it. If you are okay with that, you can just keep it like that, and it will be you can do your all that is required to change to calculate the structure. But in this case, for example, I decided to change, yes, to disable the macro, this group of the objects, and I changed, for example, for the purpose of demonstrating, I changed the section of the columns. Yes, I will not do a calculation in this case. I can say that I want to do some changes around the model, so I can basically do exactly as I worked before with advanced design. It's not a difference. The only way is that the benefit of this is that I can, for example, integrate the workflows you see between advanced design and advanced steel with the GTCX and the structure design. It's very quickly to mix the two of them. I can generate quickly a steel structure, bring it into advanced design. I'm doing some changes, and then I can apply those changes using the synchronization. So we see that there is a mix of possibilities. Also, we can do it via, so the changes, they can be just uploaded using the library of the structure designer. This is one of the possibilities. So I have updated my my frame, and it's loading with all the data. Or if I change the actual frame that what has been there, it will be updated when I reload it again, basically. So is the same. I have the same frames. I have the, we can see, yes, the columns are the one that were previously saved. And if we remember, in advanced design, we have made some changes. Yeah, so we can also do those changes very quickly here. And using the copy to all, for example, we change the section of the column. So it's very easy to do this. You don't need to practice a little bit, and it's easy really to control every detail of the structure, frame by frame. So we copy from one frame to another. So this copy to all is very powerful. It helps you to extend one information in one shot through the complete structure. So it's very powerful copy, but also you need to pay attention, of course, to not mix the things and to not do stuff by mistake. But it's saving you a lot of time. So the other part is that when we so we exported the model from advanced from the structure designer, we exported, and we of course we use it with the GTCX, and we can import it into advanced steel. If we want to do this this way of bringing the data here, it's very simple. It's the same. It's using the two workflow combined in this case to achieve to connect advanced steel and advanced design, or advanced steel to advanced design. So basically, advanced design is the key for your steel project. And why is that? Because you have a lot of benefits for advanced steel interaction, connectivity, yes? So we have a seamless transfer of geometry, easy section mapping, also the accuracy of the mapping models. You have an fast, easy, and intuitive synchronization. For example, for the supports, we are converting the foundation from advanced into supports in advanced design. We can transfer the compound cross sections from advanced to advanced design. We can transfer the options on elements like the rotation, eccentricity, and offset. So in case of changes like this, you can transfer them. And another point is that you have the same philosophy of modeling. You don't have nodes in the modeling process. It's very easy to model in advanced design. It's similar to advanced steel. You model with objects. So you do not start to control every node of the structure. As a general conclusion, we can say the following. The steel connectivity from Grytec enables steel designers and detailers to exchange data in both directions between advanced steel and advanced design, improve their daily work through time-saving, user-friendly and efficient working methods, control any detail of the synchronization process, and also advanced design is highly linked with Autodesk ecosystem. As you can have seen, there are many possibilities to exchange and to connect advanced design to advanced steel, to send information back and forth, to control the information that you receive when you enter in the model. So a lot of connectivity, and it's a strong link with between advanced design and Autodesk ecosystem. Today's session has been finished. Thank you for your attention. If you have any questions, please drop them in the chat, or you can send me an email via my email address. You can have it here on the screen. Thank you again, and enjoy the rest of the User Summit.